Let's go on to question 36. I would say it's one of the tougher question in the paper over here. But it's also a very good question to test, more like daily life. Although we don't really, I mean, if for those of you guys who bake or try making chocolates at home, you might have experienced this. So what setup this person is trying to make, it's called a Bain Marie. You can also Google and find what is the setup about. It's using a double pot method to control the temperature of the substance in the inner pot. So anyway, for this question, he wants to make some chocolates, and to do so is to melt some solid cocoa butter in the setups here. So there are two ways to melt it. Either for setup W is to melt the cocoa butter in the water bath, or we can just simply place the cocoa butter in the pan and heat it directly over a heating plate. So both ways are able to melt the cocoa butter. The only difference is whether it causes the butter to burn or not. So for this case, they tell us one information, that these heating plates can reach a temperature of 180 degrees Celsius. So after heating for some time, he found that the butter in setup W melted without burning, whereas the butter in X, it melted and became burnt. How to burn it is when we exceed the temperature of 170. Using all this information, why do you think the butter in setup W did not burn? The only difference between setup W and X is the presence of water. So what some students have written down is to write down that water is a poor conductor of heat. It conducts heat slowly from the heating plate to the butter, so the butter doesn't burn. But if this is true, heat will always still be conducted from the heating plate to the butter. Eventually, after some time, it can reach a certain temperature and be heated beyond 170. So maybe there's a chance for it to boil too, even if we were to use a poor conductor of heat. This question has got to do with something about a special property of water, a unique characteristic, as well as making use of all these numbers given to us. There should be a reason why it's 170, 180 and water, because water has a boiling point of 100 degrees Celsius. It boils at 100, and we know that when water boils at 100, its temperature doesn't change. It remains 100 until all the water has boiled into steam. So to explain for this question, why it does not burn, it is because of this boiling point of water at 100. Its temperature never exceeds 100. And the butter that's inside the pan, it can only gain heat from the boiling water, and its temperature, at maximum, it will also reach only 100 degrees Celsius, as long as we always have water that's surrounding the butter. So that's the reason why the butter did not burn. So the answer key from the school is written in this way: boiling point of water is lower than the temperature at which it burns. So it's a very simplified answer, but if you want a proper phrasing to explain how this happens, we can phrase it in this way, which is the boiling point of water is 100 degrees Celsius. I'll just write down the main key points for A part 1, which means when water boils, its temperature never exceeds 100 degrees Celsius. And since butter in setup W can only gain heat from the boiling water, not from the heating plate directly, it means that the temperature of the butter will also never exceed 100 degrees Celsius. Thus, it will never burn. So if you want a more step-by-step way, using the concept that's given, you can phrase in these steps. We have a part 2 over here, where now the butter is fully melted and he wants to pour it into a mold over here. So explain why this butter has to be in a liquid state so that he can pour it into the mold. So you have to think about some properties of liquid that we can apply to this question. So the answer for here, being 1 mark, Only one answer, which is cocoa butter has no definite shape. It is able to flow and take the shape of the mold. Then for B is also one of the common questions that usually test about surface area. How surface area affects how fast heat can be conducted. Comparing before and after, right? Comparing setup W as well as the next one, the only difference, it's about the surface area of the heating plate in contact with the pan. We have some gaps over here, which means the area where this pan is touching the heating plate, it's definitely much smaller now. Smaller surface area in contact. And what can it affect? It affects how fast heat can be conducted to it. So if there is less surface area in contact, the butter inside or the water will gain less heat. Or gains heat slower. So the entire transfer of heat from the heating plate to the water to the butter will also be slow. So for this question, just two main points, which is writing down that the surface area of the heating plate in contact with the pot is smaller or is less, so it gains heat slower. It will take a longer time to gain heat and melt. So simple answer.